Hello, hello. I am Matthew Craig, and this is going to be my presentation for the NLP final. Basically, I built a D&D monster IR system or information retrieval system, and essentially, I will get into it. Kind of jumping in here. Essentially, my problem was that in D&D there are just a ton of different monsters. There's like dragons and there's goblins and there's just all sorts of monsters. And so the problem that I had was I wanted my players and my app users eventually to have a very quick way to be able to search through monsters via different keywords. And so I ended up creating my own IR system in order to do that. So basically, I used a NLP-based search system that allowed for flexible monster queries and fuzzy matching, keyword relevance, and basically parsing through the massive JSON file to actually retrieve relevant monsters based on the user's input queries. But sort of jumping into the corpus for this, I essentially had these big old JSON files. You can kind of see on the screen a little bit, but the just for the monster JSON, it was about 10,000 lines of JSON code, and so there is just a ton of information here, and to manually parse through it and to manually find monsters that way is pretty terrible. So essentially, what I had to do was go through the JSON, extract each monster, and then I had to basically figure out what features I wanted to kind of pull from there. So the ones that I ended up determining were like the most important were like the monster name, the challenge rating, its type, the alignment, the size, and then the description of the actual monster. And then in order to pre-process all this data, I used tokenization, the stop word removal, and then attribute standardization for this. Here is basically my NLP solution. I started off with query parsing, so basically being able to find like CR greater than or less than 2. If I wanted to see like, give me all the CR challenge ratings that are like equal to 10. Essentially like the difficulty rating essentially. So like give me like a low difficulty rating, give me a high difficulty rating, and then also the type. So if I wanted to fight like a CR5 humanoid creature, I could easily find that. It'll give me a list of those different ones. I also did pre-processing of the monster descriptions, so just grabbing them out of the JSON format, and then I created a map that will essentially link the description to the monster. I use TF-IDF vectorizations. It sounds fancy. It's not too bad. It's basically term frequency inverse document frequency. So it's basically a statistic that is used for information retrieval and then text mining to basically evaluate how important a word is. For example, if I had like 3 documents like fire breathing dragon, fire elemental creature, dragon of frost and ice, because fire occurs really frequently in all those, it will essentially start ranking fire as like a less valuable word just because of its frequency. And so essentially that allowed me to kind of go in there and find the different keywords that were actually kind of more relevant to actually picking out monsters and creating my features. I also used fuzzy string matching because I was having the issue where if a user just kind of typed in the wrong letters or like spelled a name wrong or like spelled a tag wrong, it would just kind of freak out. And so I ended up using, for the tools I used the Fuzzy Wuzzy for the actual fuzzy matching. I ended up using spell check as well, but that's kind of part of the Fuzzy Wuzzy package. And then also reject parsing for the filters, which is how we're actually doing our features. And then the scikit for all sorts of stuff, but mainly for the TF-IDF stuff. Basically, I have a system here that will allow users to very easily search for monsters based on various inputs. So for this top image here, I have invisibility and CR greater than or equal to 5, and we find kind of top ones that comes up with that. And then we also, on the bottom one, kind of shows like what a type it would look like. So find me some goblins, and then its top result is the goblin, and then the hobgoblin, and then it'll just kind of keep going lower and lower until it finds one that I think matches. But anyway, I'm out of time, so thank you so much.